When you are solving thermodynamic problems, it is recommended that you use the following steps as applicable. Step 1 would be stating the problem statement, and in your own words briefly state your problem and the key information given and the quantities to be found. This is to make sure that you understand the problem and the objectives before you attempt to solve the problem. Step 2 is to draw a schematic, and in this case draw a realistic sketch of the physical system involved and list the relevant information on the figure. The sketch does not have to be something elaborate, but it should resemble the actual system and show the key features. You will have to indicate any energy or mass interactions with the surroundings, and listing the given information on the sketch helps one to see the entire problem at once. Also, check for properties that remain constant during the process and indicate them on the sketch. On step 3, state any appropriate assumptions and approximations made to simplify the problem to make it possible to obtain a solution, and justify the questionable assumptions. In step 4, apply all relevant basic physical laws and principles, for example, the conservation of mass, and reduce them to their simplest form by utilizing the assumptions made. When you are doing this, the region to which a physical law is applied must be clearly identified. In step 5, determine the unknown properties at known states necessary to solve the problem from property relations or tables. List the properties separately and indicate their source if applicable. On step 6, do calculations. Substitute the known quantities into simplified relations and perform calculations to determine the unknowns. In this case, pay particular attention to the units and unit cancellations, and remember that a dimensional quantity without a unit is meaningless. Also, don't give a false implication of high precision by copying all the digits from the screen or of the calculator. Round the results to appropriate number of significant digits. And step 7, reasoning, verification and discussion. Check to make sure that the results obtained are reasonable and intuitive, and verify the validity of the questionable assumptions. Repeat calculations that resulted in unreasonable values if necessary. So here I'm going to give you some advice as to how not to lose points when you are doing thermodynamic calculations and problem solving. And remember to write out all units in all equations to the bitterest of detail. That actually would help you to eliminate issues of dropping units while you are doing these long calculations. And also it is a good practice to use a horizontal line when you are using the numerator and denominator of functions, so that you don't miss. And as you can see, use the first form that you see over here in this example, not the second form with a slanted slash between the numerator and the denominator. So let's look at the importance of significant digits. The significant figures of a number are digits that carry meaning, contributing to its measurement precision. And there are some rules that you'll have to follow. Non-zero digits are always significant. That means any of the digits that are not zero, and zeros in between any of the non-zero digits are always going to be significant. The next rule to remember is that leading zeros are non-significant. So as you can see in this example, 0.01256, the leading two zeros in front of 1256 are considered as non-significant. Then trailing zeros, if a decimal point is present, are considered to be significant. But if there is no decimal point in the number, then the trailing zeros are going to be considered as non-significant. And as you can see in the number 29,000, the trailing three zeros are going to be considered as non-significant, and as a result 29,000 would have only two significant digits. And after doing a calculation, we'll have to round the answer to the minimum significant figures used in any of the numbers. So let's try to see these examples that you see on this slide. How many significant digits are there? So consider the number 311. So Of course, they are all non-zero digits, so as a result, it's going to be rounded to 3 significant digits. And 310, of course, it has one trailing 0, so that is going to be considered non-significant. As a result, 310 has only 2 significant digits. And 310 with a decimal, as you can see, when there is a decimal, the 0 is considered significant, and as a result 310 with a decimal would be considered as 3 significant digits. And 310.0, now there is a decimal in place, so as a result it's going to be all zeros are going to be considered significant, so as a result it's going to be considered as 4 significant digits. Then 310.00, of course there is a decimal, so as a result trailing zeros are going to be considered significant, so there would be 5 significant digits. Then 0.1256, of course there's a decimal, however it is going to be a leading 0, so these are going to be, the leading zeros are going to be considered non-significant, so 0.1256 would have only 4 significant digits. And then 0.012560, again here zeros that are leading are going to be considered non-significant, however the trailing 0 is going to be significant because there is a decimal point. So in this case the number would have 5 significant digits, and 29,000 of course would have 3 trailing zeros, and would be the trailing zeros are going to be considered non-significant, so 29,000 would have only 2 significant digits. So now let's see this problem. So the volume V is given as 3.75 liters, which would have 3 significant digits, and density rho is given as 0.845, and the 0 here is going to be a leading 0, so it's going to be considered as non-significant, and as a result 0.845 also would have 3 significant digits, and when you multiply the two together you are going to get an answer of 3.16875. However, the numbers that we used earlier, the lowest number of significant digits that we came across was 3, so as a result should be rounded to 3 significant digits. So as you can see here, the number 3.16875 has to be rounded to 3 significant digits, and here 6 which is in the second decimal place has to be rounded up because the trailing number is greater than 5, and as a result the final answer would be rounded to 3.17.